Alright, class, welcome to another edition of e-learning. Today we're going to look at lesson 9.2, the Pythagorean theorem. So our goals for today, you should be able to explain the Pythagorean theorem. You can use the Pythagorean theorem to find unknown side lengths of triangles, specifically right triangles. And I can use the Pythagorean theorem to find distances between points in a coordinate plane. So obviously here the Pythagorean theorem is named after the Greek mathematician Pythagoras. Okay, so we have his rule, right? And a rule in math we call a theorem. Okay, so his rule is the Pythagorean theorem, okay, which you can see here. So it's important to note that this is used to find sides of a right triangle. Okay, so we can only use this theorem if we have a right triangle. And the sides of our triangle, okay, it's important that we know these terms. So we have two legs, okay, so leg A and the leg B, okay, and that is where our right angle is formed. Okay, then the hypotenuse, the hypotenuse here, okay, that is the longest side, and it's the side opposite the right angle. Okay, so our theorem states, okay, a squared plus b squared equals c squared. Okay, again, where a and b are the legs, and c is the hypotenuse. Okay, let's look at an example here. So in example 1, okay, first we want to identify if we are trying to find the hypotenuse or the legs, and we want to look at what we're given. So here I can see that both the 5 and 12 are both legs, right? And C is opposite the right angle, okay? So we're finding the hypotenuse. So if I plug that into my formula, a squared plus b squared equals c squared, it doesn't matter which one you put in for a and b as long as those are both legs. So I'm just going to plug in 5 squared plus 12 squared equals c squared, right? And then we're going to evaluate. So 5 squared is 25, 12 squared is 144, okay? C squared is unknown. If I add together 25 and 144, I get 169 equal to c squared. And then just like we did in the last lesson, to solve for c, right, we're going to have to take the square root of both sides. Okay, square and square root cancel. Square root of 169 is 13, so I get c is equal to 13. Okay, in this case, our hypotenuse, again, will only be positive because you can't have a negative side length of a triangle. Right, same idea for the triads down here. So in the triads, in both of these, we are also finding the hypotenuse. So if I plug in 8 and 15 for the legs, right, I get 8 squared plus 15 squared equals c squared. This is where I said it's helpful if you memorize your perfect squares, right? So I know 8 squared is 64, 15 squared I know is 225. If I add 64 and 225, I get 289. Okay, to get c by itself, right, we take the square root. So then if you know your perfect squares, this becomes easier. C is equal to 17. If you don't know your perfect squares, of course, you can type the square root in the calculator. Okay, so that would be an option for you too. Alright, looking at problem 2, I'll switch to red. Same concept, right, but here we have some fractions, that's okay. So if I plug those in, right, I get 3 tenths squared plus 2/5 squared equals c squared, right, which is our hypotenuse. Remember when you're squaring fractions, that 2 is basically distributed to both the numerator and denominator. So I get 9 over 100 plus 4 over 25 equals c squared. Right, to add fractions, I need a common denominator. So I'll make that denominator 100. So that would give me 16 over 100. Okay, if I add those together, right, I get 25 over 100. And remember, when you're taking the square root, you could do the square root of like each piece individually. So I get, let me rewrite that so it's a little more clear, right? So if I take the square root of the entire piece, right, to get c by itself, that's like saying I could do square root of 25 over square root of 100, which would give me 5 over 10, right, which would simplify to 1/2. So c is equal to 1/2. Alright, I'm going to switch colors again so that I have room for example 2 here. So in example 2, okay, so this one, they actually gave me the hypotenuse, right? The hypotenuse is across from the right angle. So in this case, I'm finding a, right? So I get a squared plus 2.1 squared equals 2.9 squared. Okay, so if I evaluate that, right, I get a squared plus 4.41 equals 8.41. Okay, I can subtract 4.41 from both sides. Okay, so I get a squared equal to 4. Again, square root both sides to isolate a, and a is equal to 2. So my missing side length here is 2. Okay, again, a good way to check your work is you know that the hypotenuse should be the longest side. Okay, so if you plug them in the wrong spot, okay, and the side length is longer, okay, than the hypotenuse, then you know you plugged your pieces in the wrong order. Alright, same idea for 3 and 4. Again, feel free to pause the video here if you would like to try these on your own, and then play it to get to the answer. Alright, so I'm going to go ahead and plug those in. I'll stick with my purple color. So here, again, they gave me the hypotenuse, which is 34. So 16 squared plus b squared equals 34 squared. Right, evaluate 256 plus b squared equals 1,156. Subtract 256 from both sides. If we do that, we get b squared equals 900. Square root both sides to isolate b, and we get b is equal to 30. Again, this answer makes sense, right, because my two side lengths are smaller than my hypotenuse. Alright, same idea here, right? They gave me the hypotenuse, so a squared plus 9.6 squared equals 10.4 squared. Okay, if I evaluate that, and I'm using a calculator to get these answers, I don't expect you to know 9.6 squared or 10.4 squared in your head, so that I can subtract my 92.16. So I get a squared equals 16, right? Square root both sides to isolate a, and a equals 4. Alright. Example 3, finding the length of a three-dimensional figure. Find the slant height of the square pyramid. Right, so slant height, right, that should be the height of the slanted side, right, that makes sense. So if you were looking at that, right, we're really forming a triangle here that I just outlined in blue. So the slant height, right, is actually, right, just the hypotenuse because it's across from the right angle. Okay, so once again, I'm just plugging these numbers in to my a squared plus b squared equals c squared. Once again, I'm going to use a calculator here to evaluate these pieces. Okay, I did not write that in a straight line. That's okay. If I add those two together, right, that would give me 64. So square root both sides. So c would equal 8. Again, feel free to pause the video here to do the two triads on your own. Okay, and then you could play it to find out the answer. in this one, right, x is really, right, these two are the same length, right, so I know that my x is, once again, just the hypotenuse. Okay, it's okay that they used a different variable instead of c. Okay, we will do the same. So 9 squared plus 12 squared equals x squared. Okay, this one I actually know in my head, right? 9 squared is 81, 12 squared is 144. 81 and 144 would give me 225. Square root both sides to isolate x, and we find out that x is equal to 15. Okay, you guys will notice as you start to do some of these, there are some special patterns that will appear often. So, for example, one of the patterns is a 3, 4, 5 triangle. Okay, and I know that this would be, right, because if I multiply everything in that by 3, okay, the result would be 9, 12, and 15, which is the triangle here. Okay, that is not something you need to know in this lesson, right? That's just some extra information that some of you guys might have come across. Alright, same idea, right? In this example here, again, we have this triangle that I just outlined in blue. Maybe not the best choice since it's a blue shape, but you get the idea. So plug them in, right? 6.6 squared plus 8.8 squared equals x squared. Another one I need a calculator for. 43.56. 77.44. Add those together, 121 equals x squared. At least these all come out to be nice numbers, right? Square root both sides to isolate x, and x ends up equaling 11. Alright. On to example 4, okay, which is our last example. Oh, nope. 2 more examples. Oh, this is a long one. Right? Hang in there, guys. Alright, so same idea here in this problem. So it says find the distance between -2 and 5 and 4, -3. So if I plotted these points on a coordinate plane, okay, like you can see here, right, what they did to figure this out is they drew a right triangle in. Okay, when you draw the right triangle in, right, then we can find that distance, okay, which is in pink. Okay, so again, that would be my hypotenuse that I'm solving for. So if I plug these numbers in, right, I get 8 squared plus 6 squared equals c squared. Okay, we get 64 plus 36 equals c squared. 100 equals c squared. Square root both sides to find out that c is 10. Okay, you'll notice this is one of those triangles that I just talked about. Right here, everything was multiplied by 2, 6, 8, and 10 were the side lengths, which we just discovered. Okay, find the distance between the points. Okay, so same idea. Without drawing it out, okay, I can figure out from 3 to 7, that's a distance of 4. From 6 to 9, that's a distance of 3. Oh, look at that. You guys should already know the answer, right? 3, 4. Okay, we know it's going to be 5, but let's do the work anyways, right? 16 plus 9 is c squared. 25 equals c squared. Square root both sides, right? c equals 5. Okay, same idea for that next one. I'll switch colors here. Distance between 23 and 2 is 21. Okay, I'm not really worried about positive and negative distances, right? Because when you're squaring them, they become positive anyways. Okay, so you don't need to worry about that. Distance between 24 and 8 would be 16. 21 squared is 441. 16 squared is 256. This one does not come out as friendly. Oops, c squared. So that would give me 697. Okay, which does not have a perfect square root. So I'm not sure what Big Ideas ask you to do. They might ask you to leave your answer as the square root of 697. They might ask you to round, okay, which if I did that, it would be about 26.4. Okay, so leaving the square root, that's an exact answer. okay? And obviously this one is rounded, so just follow whatever instructions they ask for you. All right, now the last example. Okay, again, they drew this one out for us, so it made it a little bit easier, okay, than the word problem, right? But it said you have 50 yards north and 20 yards east of your team's base, okay? That would give me the ordered pair of this, right? So 50 north, so up 50 over 20, or the ordered pair 20, 50. The other team's base is 80 yards north and 60 yards east, okay, up here. How far are you from the other team's base? So again, they want us to solve for the hypotenuse. Okay, you might notice these side lengths and be able to do this right away. 30, 40, okay, from that special triangle we talked about. Okay, you might already know the answer, but if you don't, that's okay, right? We can do that math. 900 plus 1600 equals c squared. That would give me 2500 equals c squared, right? Square root both sides, so they cancel. So I can find out that my hypotenuse is 50, and in this case, we were talking about yards, right? So 50 yards apart. All right, guys, that concludes our lesson today for Pythagorean theorem. Again, log on, try that homework. If you're confused, you can always go back and rewatch the video. Adios.